guys about that. Here, I'll read it to you. But anyway, just for the sake of argument, this room feels 1,000 times better than what it did first period. Because first period, homeroom, those air conditioning units out in the hallway were not working. Yeah. It was unbelievably hot and humid. You notice I rolled up my sleeves. I was like, I know, right? I have arms. Yeah. This is the time of year. This is the time of year where you will still see me wearing a shirt and tie, and you'll see people like Mr. Liston wearing shorts. I know. Just saying. I do, at the very least. Anyway, for those of you in the chat, if you'd be so kind to leave a comment. I see the 3 of you that have left a comment so far. Thank you for that. I'll just, the AP question, I'll read it to you, but obviously I'm not expecting it to, solve it correctly. A university reporter claims that 60% of its basketball and football players graduate in 4 years. A reporter contacts a simple random sample of players from the past 20 years and finds out that only 46 out of 88 had graduated in 4 years. Now, mind you, that percentage is roughly 52.3%. Is there sufficient evidence? Not is there evidence, but is there sufficient evidence to write an article disputing the university claim? Give statistical justification for your conclusion.
I would say no.
Why? Here's the thing. Based on the sample that the guy gathered, based on the sample size, based on the proportion that came out of that sample, it is possible to determine the probability of such a sample being collected. And the probability of such a sample being collected is roughly 6 or 7%. Now, 6 or 7% is kind of in this kind of middle range where it's like, well, it's some evidence, but it might not be enough evidence depending on who you are. If you're the recruiter, you would say, oh, that's not enough evidence. If you are the reporter, you would say, yes, that is enough evidence because the reporter wants to write the article. Well, I'm saying you could, the answer is technically both. You could argue either way. You just have to pick a stance and go with it. So who would you rather be? Would you rather be the recruiter and saying there's not enough evidence, protecting your program? Or would you rather be the reporter saying there is enough evidence and I'm going to write this article? Yeah. You can't go wrong as long as you back yourself up with math. Anywho, moving that out of the way. My, which by the way, here's all the work on the back of the card. Oh, you can't see, it's frozen. Hold on. Here's all the work on the back of the card that they would have to do in order to get that answer. My AP kids are actually taking their test tomorrow. No, not their final, their AP test. The AP test is a separate test taken through College Board. And if they score high enough, then they get college credit for a statistics course. Yes. Woo. Excitement. Anyway. Gosh. I think Sherry took it. Pretty sure she got a 4. Yeah. Oh, yeah. I'm pretty sure she got a 4 or better. I could double check later. Yeah. That was weird. Yeah. No, of course I could look it up. I have all the College Board results. Anyway, to this. Okay. So brand new week. I have you today. I have you Wednesday, although Wednesday is a half day right before a 5-day weekend. Excitement fills the air. I assigned for you, now, which by the way, those of you that have turned in the Affine major from last week, if you've turned that in, I haven't been able to check anything this morning. So if you haven't gotten a grade back for that yet, I will get back to it very soon. But you do have the Enigma Project Phase 2 assessment, which is not due until, anyone remember? Yeah, look at these kids. Look at them. Josh, get on their level.
I'm like trying very hard, man. I don't know.
Okay. But yeah, it's not due till Wednesday, and I did that on purpose because I wanted you guys to have the time to do that. As for today, I want to continue with what I introduced to you last week. I want to continue with the Hill Cipher. But in order to do that, I need to take you through the ins and outs of matrices on the calculator. Again, trying to work through Excel, a lot of the tutorials that I looked up did not help me in terms of like creating matrices because it didn't give me the exact answer I was looking for. But I can take you guys through this very easily on the calculator. So if you would, if you do not already have them out, I'm going to need those notebooks out and open. Excitement. Oh, what a day. It has been a crazy 48 hours in the Markey household. Crazy 48 hours. On Saturday, I went to a memorial service for a friend who had died on the beach. And I had put sunscreen.
Wait, it was on the beach or he died on the beach?
The memorial service was on the beach.
Oh, okay.
Yes. But I had put sunscreen, like I on my arms, on my face, on my neck, on my ears. Like I had sunscreen. I forgot one spot on the tops of my head. And now I got a bald spot up there and it hurts. It hurts. And then yesterday, my wife got her second COVID shot. So she woke up today not feeling all too great. For those of you, anybody know anyone who had like adverse effects to the second shot? Yeah, they can be bad. They can be mild. Right now, my wife's are bad. But then my son decided that last night was the perfect night to do a little bit of a sleepwalk through the house. Have I told you about that?
Nope.
What? Come on.
No.
Okay. My son has an issue where every now and then he'll have this like kind of like sleepwalking episode where he will walk through the house and have a conversation with himself.
See?
Yeah.
I watched way too many movies. So
Yeah.
I
So
love movies.
what we've been told is don't wake him up, but just try to calm him down, engage him, and then eventually try to get him to lay back down in bed, which we have done. But there was one time where he's like running through the house, having a conversation, and then randomly tries to unlock the front door in the middle of the night. I'm like, you've got to be kidding me.
Never go to your house.
Why would you go to my house?
Yeah.
So that was around like 11:30 midnight last night. And then I couldn't go back. I couldn't sleep. I could not sleep. My son's taking up most of the bed now because he's in the bed with us. And eventually my daughter wakes up around like 4 a.m. No. She woke up. She first ignored me because I was awake because I couldn't sleep. And she ignored me and walked into my my wife and mine's bedroom. And then my wife eventually came out and said she's hungry. She says she wants dinner. And I'm like, what? And then my wife went to go back to sleep because apparently she was like asleep at that point too. And I looked at my daughter who's wide awake at 4 a.m. What do you want? Do you want like milk? Do you want like, she's like, I want dinner. I'm like, oh my gosh, can I give you yogurt? And she's like, okay. She downs a bowl of yogurt and then like basically lays down and goes to sleep for a half an hour. Like I am exhausted and I came into like 100-degree weather in this room.
You know what? It's like taking a nap.
I kind of want dinner right now, guys.
I'll get you some yogurt. Anyway, back to this. Okay, Hill Cipher.
I'm taking a cross and it's like,
Right.
back up. Like, so serious.
A Hill Cipher uses matrix multiplication to encode / decode. The Hill cipher uses matrix multiplication to encode / decode. There is a key matrix, which we will just label as matrix A, like that. That's usually what it looks like in the calculator. There's a key matrix, matrix A, which is the key that you would have to know in order to encode or decode the process. It has to be a square matrix. It has to be a square matrix, meaning a 2 by 2 or 3 by 3, etc. It has to be a square matrix in order to get this process to work. And I'm going to show you how to find this in the calculator. And this is very important, the determinant, you don't know what a determinant is at the moment. You don't know what a determinant is at the moment, but hold on, I will show you what a determinant is. The determinant of the key must not be 0 or share a factor with 26. The determinant, which again, I will show you what that is and how you force the calculator to get that done. The determinant of the key must not be 0, and it must not share a factor with 26. So it can't be even, it can't be 13, things like that. Yeah, it can't be 26 right off the bat. Could be 25 if you can get it to be. Now, here's the thing. I learned a ton about matrices when I was in college. A ton. You want to talk about like changing dimensions of matrices or eigenvalues or things of that nature? I'm your man for that because I know a ton about matrices and the process known as linear algebra, which is an advanced level mathematics course. I am not touching any of that stuff with you guys. Any of that stuff. Keeping it as simple as humanly possible. So for example, first let's talk about what a determinant is. Now, zoom. Here we go. There it goes. Good. In your calculators, which obviously you have your Chromebooks open, which is fantastic, but in your calculators, you do have that matrix button, which I did show you a little bit last week, which I want to get into the details again right there. There's that blue word matrix. You have to hit second and then that X inverse button, and it will take you to your matrix function on the calculator. Second and then that button. There we go. If I go over to edit, you have to go over to edit first. I'm going to input a 2 by 2 matrix. And it will bring up the shape of that matrix, and you can see that there brings up all those numbers. Now, just for the sake of argument, let's type in the numbers 1, 2, 3, 4. Okay, you do the same. Keep it very simple. Now, I am going to tell you that 1, 2, 3, 4 as a key matrix does not work. It does not work. The reason it doesn't work is because the determinant shares a factor with 26. Shares a factor of 26. I should say like mod 26, really, because this one's actually going to end up being negative. It's going to be negative, and then when you actually mod 26, it actually it's still a number that shares a factor with 26. But I'll show you that in a minute. Here's how you do it. What you're going to do is you're going to have to quit out of that matrix. When you're in the middle of that matrix, you can't just like, you know how sometimes when you guys try to hit clear to get out of things? Do you guys ever try to do that where you're like, I got to get out of this on the calculator, hit clear? Yeah, don't do that. If you do that, it just gets rid of that 4, and you need that 4 to stay there. So instead, I want you to get into the habit of clicking second mode. If you hit second mode, it will click out of that matrix. What function is second mode, by the way? Yeah, it's quit. It's literally quit. It'll quit you out of that matrix, and that's the habit that you really should be getting into. Second mode will quit you out of that matrix, and you need to do that in order to complete the next step. So I'm going to go back into my matrix function. I'm going to tab to the middle portion that says math. I see a guy dancing in the hallway. You see him? Y'all see him? Can we all look at him and just stare at him for a minute? Like, what's he doing? Josh, go embarrass him. Josh, go embarrass him. Go. Do it anyway. Do it anyway. Do it anyway.
Are you good, bro?
Okay.
Okay. You just saying hi.
That's good though. I like it. Okay. The first function. By the way, McTaggart just walked by. I think he was gonna go get him. The first function under matrix math is DET, which is short for determinant. Now, if I hit determinant, which you're gonna have to check this at least once for your key matrix, you're gonna have to check this once. If I hit determinant, and then I hit go back into my matrix function one more time, second X inverse, and stay on names, it'll do determinant of matrix A. And there it is right there. It's a -2. Now, unfortunately, -2, if you were to mod 26 to what, 24, you can't use that. You can't use it because it shares a factor with 26. Just for the sake of argument, check this out. Do you know how they got -2? How did they get -2 from that matrix? I just brought the matrix up for a visual effect. With 2x2 matrices, it's actually quite simple. With 2x2 matrices, oh, you're doing it. What'd they do? Kinda, not exactly. You're almost there. They cross multiplied. They did 1 times 4, 2 times 3, and then they subtracted them. Yeah. For a 2x2 matrix, it is that straightforward. For a 3x3 matrix, it is not that straightforward. But again, I'm not here to show you how to find the determinant by hand. I'm going to have you find the determinant by the calculator. Now, if you wanted 1, 2, 3, 4 to be your key, guess what? Sorry, can't do it. Because the determinant's -2 and shares a factor with 26. So someone give me 4 different numbers. Or if you just, or if you want to keep most of them the same and change one of them, that's up to you, but you can change all 4 if you want. Go.
7, 8, 9, 2.
7, 8, 9, 2. Okay. Now, even though this may give us a negative number, this could still work. This could totally still work. So let's just see what happens here. If I were to then, let's say, go second mode to quit, and I were to go second X inverse, DET for determinant, matrix A. Oh, sorry. I can't do it. Well, not just because it's a big number. Watch, hold on. -26. -26. I modded it 26. It shares a factor with 26. What's he whispering?
You got 47.
You got 47?
I thought we just put it in the wrong.
Oh, my bad. I put in the numbers that he told me, right?
No, I.
7, 8, 9, 2. Okay, so it would be 14 minus 72. So last class I did 1912, if you happen to remember. Yeah, I did 1912 because I was trying to show you Alan Turing's birth year for the sake of argument. Now, if you actually go back into the calculator and do determinant of matrix A, look what we got now. We can do this. We can totally do this. Because if I did plus 26, boom, 19. Again, the only thing you have to make sure of is that the determinant doesn't share a factor with 26 and is not 0. It can't be 0. There's a reason why it can't be 0. I'll talk about that in a little bit. So for this example, and I'll go into more of them in a little bit. For our example, come here, you. for our example, I'm letting matrix A equal 1912. I'm letting matrix A equal 1912 because the determinant of matrix A is equal to -7, which fits the criteria that the determinant must not be 0 or share a factor with 26. Let's see what we got here. Okay. Where's my paper at? Where's my paper? So now we're going to do something here where we are going to encode this matrix. Here we go. Good. Now, if you use a 2x2 key, then you can encode 2 letters at a time. I talked about this a little last week. But if you do a 2x2 matrix, then you can encode 2 letters at a time. If you do a 5x5 matrix, then you can encode 5 letters at a time. But again, the problem is, how are you going to memorize that code, that key, unless you're really good at memorizing numbers? Or there's some kind of a connection between you and another person. Imagine doing like a multi-level code where you send them like 2 ciphertexts, and the first ciphertext they decode, and then from that ciphertext they actually decode what the numbers are in the key. And then they then take that key and decode the second cipher in order to get the actual message. That would be cool. Sorry, I'm just brainstorming random ideas where I can hide messages from people I know. Although none of them will even care. So, very short phrase. I did it last week with the name Alan Turing. I'm going to do it something else right here. Let's say that I wanted. Oh, by the way, is your senior assassin game still going?
Yeah, they're still doing it.
All right. Do you know how many people are left or out or?
I don't know what's going on.
All right.
There's a lot. There's a lot still in there.
What do y'all win?
Like a $700 cash prize.
Are you kidding me?
That's really good.
What'd y'all put in? Like $10?
Yeah.
That's awesome. Oh my gosh. All right. So here's your next target that we have to encode this first. We have to encode the next target, and that is the name James Markey. No one's going to get me. Anyway. Now, because we're doing 2 letters at a time, I can already see there's going to be a little bit of an issue with the name James Markey because there's 5 letters and then there are 6 letters, 11 overall. So we would have to have in a dummy letter at some point. We'll probably insert an X at the end. It's perfectly fine. So in this case, let me see here. I got to figure out what numbers all of these are. What is J? B, C, D, E, F, G, H, I, J. It's 9. I don't have to do this for all of them. 9, 0, 12. What is E? B, C, D, E. It's 4. 18. 12. 0. 17. 10. 4. 24. There we go. Now, if you notice, I took all of those numbers and I kind of split them into groups of 2 because since I'm using a 2x2 key, I can only do 2 letters at a time. And if you happen to notice that number 24 at the end, it's lonely. In order to do this correctly, you're going to have an additional letter to put in there. Let's just use the letter X. X should be the number 23. Because we got to have all of those there. Now, the way that it's going to work is we are going to take this 2x2 matrix. 1, 9, 1, 2. And we are going to multiply it by a 2 by 1 matrix. In this case, the first one is going to be 9, 0. Don't say comma. Here's a little trick for matrices. Look at the sizes that I just put on the bottom of that thing right there. Look at the sizes. This is just a small trick for matrix multiplication, but it's necessary for understanding how to do these things properly and what size matrix to put in. This number represents the number of columns in the first matrix. And this number represents the number of rows in the second matrix. Do they match each other? Then you are allowed to multiply them together. It's a weird rule, but it has to do with the way that matrix multiplication works. Now, keep in mind, I'm not going to test you on how to multiply matrices by hand. I'm not testing you on how to multiply matrices by hand, but multiplying matrices is actually really insane. Check this out. I'm going to show you just a brief overview, but you don't have to write this down. You see these two numbers right here, 1 and 9. These two numbers are 9 and 0. Are they the same number of numbers? Two numbers and two numbers. It's the same number of numbers. It's weird, right? You would multiply 1 times 9. You'd multiply 9 times 0. And then you'd add the result, which would be 9. And then you would do it again with the next row. 1 times 9, 2 times 0, add them together, and you'd get that. But again, you don't have to know how to do that. The calculator will do that for you. Of course it will. Of course the calculator will do it for you. But I wanted to show you that the result of that first multiplication should be 9, 9. Just like, okay, why it's 9, 9? That doesn't really change much. I know it didn't change much, but we'll see what it does to the name James Markey in a minute. Let's actually do that in the calculator. Watch what I'm about to do up here with the name James Markey. First, I'm going to go to Edit. Oh, can't see it. I'm sorry. There we go. I'm going to go to Edit, and I'm going to go down to Matrix B. Matrix B. I'm going to make a 2 by 1 matrix. A 2 by 1 matrix. And I'm going to put in 9, 0. 9 representing the letter J and 0 representing the letter A. If I do that matrix multiplication correctly, which is matrix A times matrix B, look what it spits out. Exactly what I said it would. 9, 9. It's weird. It's very weird. J was encoded to itself, and A was encoded to J. It's very weird how the letter pairs actually work together. Now, I'm going to do the same thing for the next letter pair. I'm going to do the same thing for the next letter pair, but I'm going to show you a little bit of a shortcut. Get ready for the shortcut. Get ready. You ready? You ready? Shortcut time. What's the next number pair that I need to be inputting? What's the next letter pair I need to be inputting? Check this out. 12 and 4. Ready? Second mode. Second enter. A little bit of a shortcut. I changed matrix B, but it's the same calculation. 48? What do I have to do to that? Yeah, you got to mod it, which you could easily mod it. Just like, boom, boom, subtract 26. So let me go through them one at a time and kind of write out what these things are going to end up being right here. If I do this multiplication one at a time, it ends up being the numbers 9, 9, 48, 20. Let me do this calculation again. but I'm going to change it to 18 and 12. Do the calculation again. I get 126 and 42. I'll have to mod them later. 126 and 42. You know, remember the Beal cipher from earlier this year?
Yeah.
I was thinking, what if it was like a mod 26 deal? What if it was a mod 26? What if you had to mod 26 it, and that actually was the ciphertext that we would then have to work with? I'm not giving up on this treasure. It's going to lead us to Enigma. It won't. Enigma's already been solved. 017. Boom. 153.34. Again, if you get swift enough with the calculator, you could easily knock out these calculations. You just have to know the commands for getting them done. Second matrix, edit, 10, 4, boom, 46 and 18, and one more time, 24, 23. Boom, 231.70. Let me move my calculator, zoom out a little, and show you those numbers. These calculations are enciphering this information for us. But of course, like we talked about, we are going to have to decode. We are going to have to work backwards. What is this? Sorry. I got an email about one of my students who is opting out of taking the AP test. Literally taking it tomorrow. Opted out today. Thanks. Anyway, but this isn't the encoding process. It's just a straightforward multiplication. Now I'm going to have to mod this stuff. I'm going to have to mod 26 it. So I'm going to do that real quick right here with the calculator. This should be a 22. This should be another 22. Should be a 16. This should be a 23. This should be an 8. This should be a 20. This should be a 23. This should be an 18. And then it's just a matter of putting them into their letter form. This is the encoding cipher. What is this? A 99. So it should be a JJ. What is that? W U W Q X I U S X S. Look what the name James Markey turned into. It would be amazing if you guys were given the names just in code and you had to decode it. Be insane. But that's what the name James Markey turned into. You can see a lot of repeated letters. You got a couple of J's up front, but that was originally J-A. M was this W. E-S also became this W. You can have repeated letters in this system. M-A, there's the A in Markey. R-K-E-Y, there's the Y in Markey. The A and the Y both became an X. This is insane how this works. The way that these letters are pieced together, the way that the matrix multiplication is supposed to work out, this is what ends up happening. Very, Very strange. Now, in terms of working backwards, it gets kind of dicey. First, let me show you some of the pitfalls that you are going to have with working backwards, okay? Because you do have to understand the direction of how you're actually going to be doing this matrix multiplication. I really need to look up that Excel thing. Okay, tell you what, this is what I'm gonna do. First, I wanna show you some of the pitfalls of matrix multiplication. And then I wanna take another shot at looking up that Excel tutorial because I really want it to be faster for you guys. I really want it to be faster. Can't Excel do anything? It can, right? Excel could make coffee, I think. No? Maybe.
Maybe you like program it into a coffee.
You could. Oh my gosh. That's $1 million idea. But yeah, what I would like to do is I'm going to show you some of the pitfalls of matrix multiplication. And then I want to work through, I want to look up very quick. I'm going to take like a quick break and try to look up a tutorial again, because I know that I can do this. I probably just need to look up like a YouTube tutorial, some junk like that, because I've been just looking at text-based tutorials. Anyway, I'll think about that while I finish up the pitfalls of matrix multiplication. Okay. Check this out. First of all, look what I'm about to do here. Look what I'm about to do here. This is a mistake waiting to happen. Look up here. This is a mistake waiting to happen. This matrix B was a 2x1 matrix. That was a 2x1 matrix. Matrix A was a 2x2 matrix. What's wrong with that? These two numbers do not match each other. What do you think is going to happen when I hit enter? A what? Let's see. It says dim mismatch. The reason why it says dim mismatch is because of those numbers. It was a 2x1 matrix and a 2x2 matrix. Mismatch. Can't do it. You can't do it. So you have to, number one, make sure that you are multiplying these things in the correct order. You have to make sure that you are multiplying these things in the correct order. You have to. It's kind of a pain, but that's the joy that we have to go about doing these things. Next. So hold on. Zooming out. Okay. A times B, and I'm going to put these in little brackets right here, gives you the encoded numbers. Now, these encoded numbers, that's really small. I'll make that bigger. There we go. Those encoded numbers, then obviously we convert to letter, or no, we would have to mod 26 them, and then we convert them to letters, all of that fun stuff. But then working backwards takes a little bit of kind of diciness here. See, if we want to decode, we are going to have this kind of combined matrix A and B thing to get these numbers. Actually, I'll give you the first example. I'll write it down one more time. What we did was we had 1912 times the matrix 90, and it gave us 99. Matrix A was the key, matrix B was our plain text, and then the last matrix was the encoded numbers. But if we want to work backwards, what we're going to have to do is something a little bit weird. And I'm going to write this a little bit in red so you can see what I'm referring to. I'm going to write this in red. Well, the important parts, I should say. There we go. Look what I wrote in red here. What the heck is that? What the heck did I just write in red?
Exponents.
Kind of.
The
Inverse. It's the inverse. You guys have been dealing with inverses forever. You guys have been dealing with inverses since like pre-algebra. Mr. Markey, no, we haven't. Yes, you have. You've been dealing with inverses forever. For example, if, I don't know, I had a 3 plus x equals 7, what is the inverse operation to that 3? Yeah, you subtract it. You subtract 7, or maybe you add in a negative 3. You could also, and I'll put this in red here. Yeah, here we go. You could add in a negative 3. I'll do it like this. I like the colors. Yeah. There we go. And when you perform this calculation, these two are supposed to cancel each other out, leaving you with the ultimate answer. The same thing is happening here. If you were to apply A inverse to this matrix, they theoretically should cancel each other out. And then the resulting matrix over here will produce our plain text numbers, kind of. There's going to be a little bit of finagling that we're going to have to do, just like before. Because with this matrix multiplication, it's going to be a little bit weird. So the other reason why we need to have square matrices, because you can only really do inverses like this with square matrices. So here's what I'm going to do. We are going to figure out a 3x3 example that we are going to encode. I'm going to set you guys up, and then I'm going to give you some practice working with the calculators on the Chromebooks, where you're going to take a message and you are going to encode it. But we're all going to encode the same thing. I want you to get practice with those matrices in the calculator. Really, really do. But first, if we're going to do a 3x3 matrix, we have to come up with a 3x3 matrix that has a proper determinant. We have to come up with a 3x3 matrix that has a proper determinant. So here's what I need you to do. Go back to your matrix screen. Go over to edit and change that matrix to a 3x3 matrix. You can see, obviously, it pops up the last row and last column. Now, we don't have to use 1912. We can use any number we want. But check this out. I want to show you something that doesn't work. Check this out. You'll see what I did? I just did 1, 2, 3 across every row. Watch what's going to happen, because this is not going to work for us. This is not going to work. It is not going to work. In order to use this as a key matrix, the determinant of this matrix has to be a number that does not have a factor of 26 and does not equal 0. Determinant, matrix A, I got a 0. Can't do it. I can't do it. If you're going to use a 3x3 matrix, you have to have a matrix that has a determinant that is not 0 and not a factor of 26. So, can you come up with a 3x3 matrix right now that actually does have a determinant that we can use? Can you come up with a matrix right now? The numbers don't have to have any significance to them. They don't have to have any pattern to them. I just need a determinant that is going to meet the qualifications of what we need. I'm going to try another one. I mean, if you get it, did you get it? Oh, you were looking at me like, Josh got it?
No,
Josh, what numbers did you get?
Josh did not get it. I don't know what we're talking about.
I just need numbers that could potentially create a determinant that is not 0 and doesn't have a factor that is shared with 26. Any suggestions? Let me see if this one works. I have one from a listing example. I just want to see if it works. And then I'll show you what he did, if he's correct. Oh, I got one too. You got, what'd you get? Oh, hold on, one second. All right, do it again. 783 415 692. Are those the correct numbers that you have?
Yeah.
Okay. Oh. Determinant of matrix A, negative 35. Let's see. Hold on. Plus 26, plus 26. That should work. That should totally work. Can I show you the example that Liston came up with? All right, because here's the thing. We could use yours, but I want to use Liston's for our example, actually, now that I saw what his determinant was. Check this out. You ready? Watch this. He has a matrix right here on the far right side of this example, which he uses numbers that I don't think that you guys thought about. Yeah. Look at that. Look at these numbers. I'll leave these up here for a moment because I want you guys to use these. So please copy these in to a 3x3 matrix on your calculator. That would be wonderful. Copy these into a 3x3 matrix because I want to make sure we all get the same thing. 1, -2, 2, -1, +1, 3, 1, -1, -4. Now check what happens when I do the determinant. Watch what happens when I do the determinant. Oop. Where are you? There you are. Look what he gets right on the dot. Good for him. Good job, Liston. Doing your things. Doing your Liston things. Wearing shorts. I can keep going. Watching cryptocurrency crash this weekend. Well, the Bitcoin was over almost at 50,000. Now it's like lost like what $15,000 worth. Insane. Now Liston has a bunch of cryptocurrency. Anyway, here's what we're gonna do. We're gonna take this matrix and we are going to use it to help us encode a message. We are going to encode a message. So we got to come up with a plain text message that we are going to put into this. And I'm gonna have you guys knock this thing out. I wish I had a mess. I want to do something like meaningful. I used to have a bunch of like mathematical quotes around my classroom, but I took them down because I didn't know how long we'd be in the classroom in the beginning of the year, and then time went by, and then stuff eventually got away from me. Anyway, but I have a bunch of mathematical quotes somewhere. I hope I have an Alan Turing one. Actually, let's look up an Alan Turing one. And then we'll do this one, a short one. Alan Turing quote. That's a good one, yeah. Now, mind you, since we're doing a 3x3 matrix, we can take it 3 letters at a time, right? Machines take me by surprise with great frequency. I'll flip that over to you guys. I'll get you started, but then I want you to encode this thing the best that you can. Now with these, since you're taking 3 letters at a time, since you're taking 3 letters at a time, let me help you separate these. Three letters at a time. H-G-R-E-A-T for E. Holy crap. It worked out perfectly. Josh, you've done it again.
That's not one. That's not one for the day, man.
It's your one for the day.
I'm gonna sign off after this.
So here's what you're going to do. You're going to take this quote, machines take me by surprise with great frequency. You are going to convert it into numbers. You are going to use those calculators to perform the calculation with our matrix key, which in this case, our matrix key, let me just write it down for the sake of argument and completion in my notes, should be 1, -2, 2, -1, 1, 3, 1, -1, -4. And you are going to encode that sucker using that key matrix. Now remember, you're going to be multiplying. Do you remember what size matrix B should be?
Was it had to be a 2 by 2 this time? Or
Well-
3 by 3?
Well, we're using a 3 by 3 in matrix A. The one you should be multiplying by matrix B should be a 3 by 1. Now you can take 3 letters at a time. You can only take the number of letters at a time as the size of your key. So if you had a 5 by 5, you could do 5 letters at a time. If you had a 10 by 10, you could do 10 letters at a time. Now you can do 3 letters at a time. I want you guys to encode that. Boop. And I want to see about this. Excel thing and see if I can't decode how Excel is supposed to knock this thing out.
Maybe you can make your coffee.
Nah, I'll make my coffee my way later. Listen. Hold on. Let's see, 16. That's not us. Okay. All right. Excel has not done me any favors.
Can't trust him. Confident yet.
Nope. Can't do it. I won't trust it. Every time I try this thing with Excel, every single time I try this thing with Excel, it ends up like it doesn't spit out like a 3x1 matrix, for example. For example, let me just show you.
A lot of Google Sheets.
It has the same issues. It has similar issues. Check this out. Now, I might be missing something, but when I do this, for example, there are my first three letters right there. 1202. I'll show you exactly what Excel's been doing to me and why I've been having such problems with Excel. See, the thing is, I'm doing all this stuff with Excel. Liston never did this stuff with Excel. You know what I'm saying? So he doesn't understand the Excel knowledge that I have. And I'm frustrated because Excel is supposed to be my friend. That's what happens, Josh.
Huh?
Anyway, so if I multiply matrix A times matrix B, I get this. Now, these are not not all of the numbers that I need because I can't do -6. I'm going to have to mod 26 it. Cool. So -6 plus 26 would give me 20. So the first three letters, MAC, are supposed to encode to 16, 20, and 4. I'm assuming you guys got similar numbers? Right. When I do this in Excel, the only thing that Excel tells me is 16. That's all that it tells me. I'm like, what are you talking about, Excel? Here, I'll show you. Hold on. I closed it out, but I'll show you what I'm referring to. So here is I'll zoom in. Here is my matrix A. So I got 1, -2. Probably should do equals -2. Will that do it? Oh no, was that what I was doing wrong? Hold on. If this works, then I may have cracked it. If this works, holy crap! I'm excited now because, well, I'm probably wrong, but hold on. Nope, that's a -2 or -1 equals -4. Why is this thing here? Inconsistent formula? What are you talking about? Inconsistent formula. Okay, so that's matrix A. Cool. Here's matrix B. And what was matrix B? The first one was 12, 0, 2. Equals 12, equals 0, equals 2. Okay, now check this out. I'm going to put a little box around here. A little box around here. Now I'm going to multiply the two of them together and get the answer here. Okay? Boom. So this should, I highlight all of those, equals matrix multiplication. You see the function right there. Array 1, comma, array 2. Right? Yeah. This is what it keeps doing to me. It keeps just showing me the 16.
Maybe this doesn't like 20.
I don't know. But no, but regardless of the numbers that I use, it keeps only giving me the first number, which clearly we know it's the 16. But I want the rest of the numbers as well, so I don't have to keep using the calculator. So that's the frustration that I was running into. Anyway, let's just knock this thing out. And then, yeah, we might end up calling it a little early. We'll see. Let me just give you what these numbers should end up being. So I got 1624. Let's see. HIN. What did you guys get for HIN? What numbers were they? Oh, no, I'm sorry. The original numbers. B, C, D, E, F, G, H. 7, 8. Oh, duh, why did I know that? 7, 8, 13. I just want to show you how quickly these things can kind of roll by. If I can actually get the maneuvering down. You guys might be better off using like the handheld calculators for this thing, because they tend to run a little bit nicer. Boom. So it should be 17. I can't do 40. 14, and I can't do negative 53. 25. There we go. EST. See, this is going to take forever. So let me just do the first few then. I'm not going to take your time wasting all this time because I really just want to use Excel. B, C, D, E. So 4, 18, and 19. I'll just do the next few here. There we go. 6. Josh, why'd you pick a long phrase?
It's not that. The shortest
14. Boom. So just for the sake of argument, here are the first 6 numbers that you should have gotten that would have corresponded to machines and then the letter T. So this should have been, what is this? O, P, Q, yeah. Q, U, E, R, O, Z, G, T, and O. Those should have been the first 9 letters from the word machines. So, and ciphering is not that bad as long as the phrase is not that long. As long as it's not that long. You just have to make sure that you have the proper, you just have to make sure you have the proper matrix there. But again, I don't understand why Excel is not doing what I want it to do. I really don't. It's a little frustrating. Okay, so here's what I'm going to do. I am going to, instead of having you guys like knock out the rest of this phrasing and then do that, I'm going to spend a little time messing around with Excel because I just need some like time to just me and Excel to like fight it out in a room, and I'm going to come out the victor with some code on my face that I'm just punched in. Whatever. Anyway, I'm talking nonsense because I'm on like 3 hours sleep. No, I'm on like 4 hours sleep. Hold on. I can prove it to you. You know anybody who wears a Fitbit? You don't? Whatever. Check it out. This was my sleep last night. Can't see it that well. Hold on, let me zoom in. Get rid of that. There we go. All right, get rid of that. Zooming in, zooming in. You see all those reds? Those were the times that I was awake. So, yeah. So my son came in around like 11:30, and I was awake for a while. And then eventually I passed out on the couch. And then at some point, because I was supposed to be asleep by like 10, but my son's thing was a whole big deal. And then eventually my daughter woke up, and then she woke up again. And then here's me trying to get her some yogurt. And then this big red line. I was legitimately just awake the whole time. I don't even know why. It should have just stopped counting. But this was my sleep pattern last night. Oh my gosh. Anyway.
You have decent.
between midnight and 1:30.
Yeah. The rest is just light. You're like basically awake.
Yeah, I know. Oh my gosh. Yeah, the deep sleep was just like an hour right there, an hour 4. Anyway, but yeah, so here's what I'm going to tell you can do for the time remaining, because we have until 10:10, and then I get to take you down to lunch, and then Josh gets to go wherever he wants apparently because he's special. He's a cool kid like that. Sure. But you do have due on Wednesday the Enigma Phase 2. Now, obviously, there is the one cipher that you do have to decode, number 1. But then number 2, obviously, there's a little bit of the write-up on the enigmatic character. Don't say it. But I'm pretty sure at this point we should know who the enigmatic character was. And if you don't, we're going to have a bit of an issue. Oh, goodness. Anyway, I'm going to go make a cup of coffee and battle it out with Excel, because Excel can't make it for me, apparently. And then you guys are going to work on that. So for those of you in the live stream, I see you right there. Again, still just the 3 of you. I am going to leave this open just a little bit longer in case you have questions. But your task right now is to either finish up or begin working on the Phase 2 Enigma project, which is due on Wednesday. So, and then I got to figure out this Hill Cipher thing, because Excel does not want to do me any favors. Me? No, I can't take a nap. Never lost. I can't nap. I got to keep going. Keep moving forward. Oh, that's what I forgot to give her. And I forgot to sign that. Sorry. I'm talking about things that happened like days ago. Let's see here.
What time? I was like sitting.
Oh, yeah. Oh, yeah, that's right.
Yeah.
I may have figured it out. No one's excited.
Woo!
I may have figured it out.
He figured it out.
I'll show you exactly what I was missing. You ready?
Did you forget to carry the zero?
No. I didn't do any of that stuff. Oh, watch this. Ready? Okay.
Everyone watch.
Just watch. So I highlight the result matrix. This is where the result matrix should go, right? Equals. Now you see it's still highlighted, right? Paste. Now I have an extra equal sign there. That's just an accident. But you see it says M multiplication and then the matrix A times matrix B.
Yes.
Instead of hitting enter, in order for Excel to accept the fact that this is a difference, this is like a sized like formula, I have to, in this order, hit Control, Shift, Enter.
Oh, I didn't even think of that.
Isn't that messed up? That was the only thing I was missing, which means we can encipher these things a lot faster. Heck.
Yeah, dude.
No, you're not.
Yeah, yeah. You? Yeah.
Because then I wonder, hold on, can I then apply this to it? Check this out. Hold on. So insert, and then I do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And then I do 0, 1, 2. Bring that down. There we go. Highlight that, make it center. Okay. So then, where's my quote? The quote was machines take me by surprise with great frequency. Okay. Now this matrix B, I would copy this all the way down here. So I wonder, sweet, okay. Hold on. Equals, look up, parentheses, F2, but look it up there, comma that. Boom, that was a 12, boom. Okay, it gave me all of those, but that's okay for now. Let's just get rid of that. Get rid of the border, there we go. But it converted all of them to numbers, right? 7, 8, 13, there it is. 4, 18, 19, there it is. And then the resulting matrix, I'd have to copy paste. No. Oh, I know what's gonna happen because it's gonna shift down in red. Okay, so then let me put a little dollar signs here. You guys don't know about the dollar signs yet. Okay. And actually, let me mod 26 this. I don't know if it'll work though. Yeah, I'm gonna have to mod 26 it separately. Yeah, I'll mod 26 it separately. But then I'm running out of time because the bell's. I got 1 minute to figure this out. Paste. Yeah, Control Enter. No. No, it's not gonna work there unless I do copy paste. Oh. Paste. Got 30 seconds. Paste, 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 paste. And then equals this number. No. Equals mod this number 26. Boom. Equals lookup parentheses J2 comma this, enter. Ah, come on. What did I do wrong? Oh, it's the number. Right. So this has got to be, I'm running out of time. The bell's going to ring. This, comma, this.
Oh.
There.
So close. Seconds away. Seconds.
Look what Excel can do.
Stop. And it can make you coffee.
And it can make your coffee.
And it can make you coffee.
Well, maybe.
Amazing.
Test that.
Anyway, we got to go to lunch. Thank you, guys. Sky is excited. She just all caps. She's like, yes, you did it.
Yeah, but we still didn't do the clock, almost do the clock.
Josh makes me sad. I'm going to sign off.